Hey students, this is lesson 3.7. We're going to learn how to solve equations and inequalities involving absolute value. I put the definition of absolute value on here for you so you can just be reminded of that the absolute value is the distance from a number to zero on a number line. And so that tells us that the absolute value is always greater than or equal to zero because distances are never negative. All right, go ahead and do this review, and I'll check back with you. All right, so solving an absolute value equation. So we're looking for the solutions of the absolute value of x plus 3 equals 7. So in terms of the definition of absolute value, we're looking for those numbers that if you add 3 to them, their distance from 0 on a number line is 7. So we can use properties like the properties of equality to help us solve this. As long as it's outside of the absolute value, we don't want to do anything inside. But we can add 3 to both sides without creating a problem, and we end up with the absolute value. Oh, maybe I should subtract 3 from both sides. So we get the absolute value of x is 4. And what that means is we're looking for numbers that are 4 units from 0 on a number line. And there's actually 2 of them, if you think about the number line here. -4 is 4 units to the left. +4 is 4 units to the right. So both those numbers have an absolute value equal to 4. So we're going to say x equals 4, or x equals -4. And if you want to do a shorthand for that, we can just say x is equal to plus or minus 4. All right, and you might want to check those. So if you were to put -4 into that absolute value and add 3, it would have to equal 7. And the absolute value of -4, the distance from -4 to 0 is 4 units. And that's true. And then our other value, +4, that looks like this. And the absolute value of +4 is also 4 units from 0. And that's also true. So we have 2 solutions in this case. All right, I'm going to let you try that. All right, key concept, solving absolute value. To solve an equation with more absolute value of a equals b, where a represents a variable expression, you actually solve 2 equations, one for when that equation without the absolute value is a positive number and when it's a negative number. So, and we just saw that to solve the absolute value of b equals 3, you want to solve b equals 3 and b equals -3. So there's 2 solutions because both negative numbers and positive numbers are the same distance from 0 on the origin. So to solve this, we're going to solve x minus 5 equals 6 and x minus 5 equals -6. To solve this one, we're going to solve h plus 7 equals 2h and h plus 7 equals -2h. All right, so let's do a problem and you'll see how that works. So your cousin was standing along the parade route when she spotted a float 250 feet from her. The parade was traveling at 150 feet per minute. Distance d from your cousin in feet after t minutes is given by this equation using an absolute value. At what times is the float 200 feet from your cousin? So this is our distance, 200. Now, what you have to remember here in a parade, it can be 200 feet before or 200 feet after, and that's why we're using the absolute value here to help us deal with that. So we're going to substitute 200 for d, and we get this. And so what we want to know here, okay, so in terms of real numbers here, we're talking about being a -200 feet, which means that's after the float pass, and being a positive is before the float pass. So we got two equations to solve here. Negative 200 is equal to 750 minus 158t. And positive 200 is equal to 750 minus 158t. Okay? In both cases here, we are going to subtract 750 from both sides to solve it. So we get subtract 750, we get negative 950 equals negative 158t. Subtracting 750 here from both sides, we get negative 550 equals negative 158t. And now we want to divide by negative 158. And we get about 3.48, somewhere in there. And over here, when we divide by negative 158, we get about a little over 6. Okay, so the first time we see the float will be about 3.5 minutes. The second time we see the float will be about 6 minutes. All right, so our answer is D. All right, I'll let you try that. All right, so in solving an absolute value equation, in this case, and I'm just going to give you a couple steps that you can always use when you're doing that. Step 1, isolate the absolute value expression. And step 2, is to write your two related equations. All right, so in this case, to isolate the absolute value expression, we're going to start by subtracting 6 from both sides. And after I do that, I end up with this. And actually, right now, I'm just going to stop. Well, I can divide both sides by 5. So let's do that. But I'm worried about something here. I hope you guys noticed that. And so that's negative 0.6. And right here, this is what I'm worried about. No matter what's inside here, when I do the absolute value, it's going to be a positive. So there's no way I can get negative 0.6. So at this point, I'm going to just say there's no solution. And that happens if after you isolate the absolute value part, you're trying to make it a negative. All right, so you try that. All right, in solving an absolute value inequalities, instead of having two equations where one is equal to negative and one is equal to positive, we actually have two inequalities. Or one is all the numbers on the left side of 0 or less than or equal to, and the other ones are greater than or equal to. So what happens is we end up with two different inequalities. So if it's greater than 3, the distance from 0 is greater than 3. That means that either the distance is 3 and greater or negative 3 and less. So that would be this possibility here. So all these numbers, all the times 5x is less than or equal to negative 3, the absolute value of that is going to be greater than 3. Oops, it should be actually this one because it's not the equal sign. Sorry about that. All right, and the other example, if it's less than 5, that means the distance is on a number line. If it's less than 5, it's somewhere in here. So it's somewhere in this zone, which means it's greater than negative 5 and less than 5. And that would be that choice there. Okay? So, it's a little tricky when you're solving an absolute value, but I'll show you how it works. So we want the absolute value of 5x to be greater than or equal to 20. So that means our 5x without the absolute value must be greater than or equal to 20, or it can actually be less than or equal to negative 20, because all the numbers that are less than or equal to negative 20 are more than 20 units from 0. So now I'm just going to solve it by dividing both sides by 5. Solve this one by dividing both sides by 5. And we get 2 parts of our solution, and it's an OR. So greater than or equal to 4. So I'm going to put solid circle there and color this way. Those numbers are all greater than or equal to 4. Less than or equal to negative 4. Those are over here. All right, you try that. All right, so this is a situation where we're dealing with less than or equal to. A professional athlete normally runs 1 mile in 224 seconds. The athlete wants to run within 6 seconds of the normal time. What is the range of allowable times? Well, I hope you're thinking you would just subtract 6 and add 6, but we need to learn how to use absolute values, so I'm going to show you how that works here. So if I take whatever the athlete's time is, and I subtract 224, which is the normal time, I'm going to get some values, and those values can either be positive or negative depending on whether or not the athlete is above or below that time. So we can deal with that by just putting an absolute value around that and say that needs to be less than or equal to 6 seconds. And now when you have an absolute value and it's less than, that means when on a number line, either any numbers that are between -6 and 6 will have a distance that's less than or equal to 6 from 0. And so I can just create a compound inequality for this without the absolute value, and then just solve that by adding 224 to each part, and I get 218 is less than or equal to t is less than or equal to 230. So the times range from 218 seconds to 230 seconds. Go ahead and try that. All right, that's it for the lesson, and I'll see you in class. Go ahead and do the lesson check to be ready.